Hi, I'm Rich with insideHPC. We're here at the GPU Technology Conference in Silicon Valley, and I'm here with John Stone from the University of Illinois. John, thanks for having me here, but a question for you. I heard you've deployed some software with containers on the NVIDIA GPU Cloud. First of all, what are these containers and why would you want to do that?
So containers are a way of packaging up an application and all of its dependencies in such a way that you can install them collectively on a cloud instance or a workstation or a compute node, and it doesn't require the typical amount of system administration skills and involvement to put one of these containers on a machine. And within the container image, in a manner that's roughly similar to what you have in a virtual machine, the user can change anything they want. So you have an entire sort of a operating system snapshot is what it looks like on the inside. So you can customize the layout of the file system and do all kinds of things that would otherwise involve getting a lot of permission and cooperation, particularly in large computing installations.
Well, I understand you have a demo using these containers. Can you tell us about that?
Sure. So what we're showing here is two of our programs. We have actually our NIH centers put three different software packages into the NGC container registry. One is NAMD, which is a molecular dynamics simulation program, and that's what's running in this text window here as it prints timing information and so on. Another one is VMD, which is a molecular visualization and analysis tool that I'm showing here. And the third is lattice microbes, which simulates entire cells. So NAMD is doing a simulation of satellite tobacco mosaic virus, which is shown here. This is the NGC container image. It's been pulled down to this. This is just a workstation, an NVIDIA DGX station. So it has 4 Volta GPUs. Basically all they've done is they pulled down a copy of NAMD. This is one of our standard NAMD benchmarks. They are basically running the container image on this workstation, and so you have what to the user would look like a little virtual machine in here. If you go and look at what's going on in here, this looks like it's a little separate computer. Has its own file system image, which is structured for the benefit of NAMD. And then what's going on here is NAMD is communicating with VMD interactively in real time, and VMD is showing the atomic structure as it undergoes the simulation. So you can see the atoms wiggling around here. If we had a big enough computer, we'd actually be able to see the dynamics much more rapidly. But this is just a demo to show the technology.
Well, kind of a wrap-up question. We're in HPC, right? This is all about performance. Does this slow things down?
Not from what I've seen so far. Certainly our applications have run fine. Part of the quality assurance process that we went through to get our applications in NGC involves running benchmarks to validate that the software is running at an expected level of performance and that it's getting good utilization out of the GPUs. And they tested on a bunch of different types of machines. So we ran on various kinds of DGX stations, single GPU machines, and so on. And my original deployment test platform was actually the Amazon EC2 instance.
Well, John, it sounds like these containers are going to help people focus on their science and not how to get the thing running on the big machines. And thanks for sharing this with us.
Thank you very much. Yeah.